Hello everyone, we're going to talk about percent composition or mass percent. It means the same information, so these questions could ask you determine the percent composition or determine the mass percent, and just be aware that they're asking for the same information. This does have an equation here to calculate the percent composition or the mass percent. And what it is saying, let me just put these both in parentheses. It's saying to take the total mass of the element within the compound and divide it by the molar mass of the compound. You multiply it by 100 because that's going to put it into a percentage. All right, so let's see what that means just in regular terms here. So let's say I have some gum here and I want to know what is the mass percent of sugar in a stick of gum. So when I have a stick of gum, what is the percent of mass that that gum makes up for that entire mass of that one stick of gum? So for instance, let's say I take one of these pieces of gum and I weigh it on this digital scale and it weighs 6.78 grams. All right. Then I'm going to chew the gum for 5 minutes. All right. Because when I'm doing that, it's going to dissolve the sugar that's in the gum. Then I'm going to spit it out and just kind of let it air dry there. And then I'm going to weigh the chewed up gum that now doesn't have the sugar in it. And then I'll be able to determine, hey, from that original piece of gum that was not chewed, by mass, how much did sugar make up that mass? We use this information eventually to determine empirical formulas, which will be another video lecture. So let's just use this based on the piece of gum. So I'm going to take the mass of the regular gum, and then I'm going to take the chewed up gum that I spat out and let it air dry. And that difference in that mass is how much sugar by mass was in this original piece of gum. All right, and so when I want to find out what that mass percent is, I'm going to take the mass of the sugar, which is 1.83 grams, divided by the total mass of the gum, all right? And then I multiply it by 100 to get that percentage, and I get 26.99%. So 27% by mass, this was made up of just from sugar. All right, so that's how much sugar by mass was in that gum. Again, we use this information eventually to determine the formula of a empirical formula of a compound. All right, so let's do some problems here on percent compositions using that formula. Students who get this incorrect miss this part of the numerator of this equation, which says take the total mass of the element. So a lot of times, even though it might have 6 carbons in it, they'll just take 1 carbon. So it is important to know how many you have of each element in the compound. So by mass, we're going to determine how much each of these elements make up this molar mass. So I'm going to take how many carbons I have, which is 2 carbons in this compound, times it by the atomic mass of carbon, so you'll need a periodic table. And then I'm going to divide it by the molar mass, which was given to us, multiply it by 100 to get a percentage, and it's 37.8%. Okay? So almost 38% of this molar mass is coming from just having carbon in it. The next one's going to be hydrogen, and there's 5 of them in there. Depending on your periodic table, this mass of hydrogen may be a little bit different. You might have 1.01 grams. What would help if I could write my numbers correct? It's 1.08 grams. Too many zeros in there. Divided by the molar mass of the compound, times it by 100, and we'll see that almost 8% of the molar mass is coming from hydrogen, so just a small little portion. I'm going to do chlorine the same way. Again, I have 1 chlorine, and then its atomic mass is 35.45 grams, divided by the molar mass, multiplied by 100, and that's going to be 55.8%. All right, now all of this should add up to about 100%, but we're not carrying all these numbers, so we're rounding up. When I did this, it was more than 100% because of the rounding, but just know that all the percents add up are roughly to 100%. Now, I could have stopped after hydrogen and determined chlorine by this thought process. Does that all of them add up to 100%? So I could have taken 100% minus the percentages I had already done, which was 37.8 plus 7.9. So I had done it for carbon and hydrogen already. So if I took it from that they should all add up to 100% minus what came from each of those, this method gives me 54.3%, which is a little bit different here because, as I said, we didn't carry all the numbers through. Close enough, I would be fine with that. Now, this one asks for each individual element to be done. Most of the time, they're just going to ask for one element to be done. So this is a typical test quiz question where it's just asking for the oxygen. So let me do the same thing here and provide the molar mass to save a little bit of time. So the molar mass of, and this is sugar, is 180 grams. So just interested in oxygen, then remember it does matter that there's 6 of them in there, times by the atomic mass of oxygen, divided by the molar mass, times 100, and that's going to give me a percentage, 53.3%. So over half of this molar mass comes from just oxygen being in there. So that's pretty significant. All right, so on a quiz or an exam, you would be showing work or it would be a multiple choice. And for some reason, some students in this part can do one or the other. But to do both is where it seems to fall apart for some. So if you can do this, you should be able to do a multiple choice problem. If you can get the multiple choice correct, you should be able to show your work. All right. There are practice problems down here. All right. That is asking for every single element that is in the compound to determine the percent composition. As I said, on a test or a quiz, it would just be one of those elements, but this is just for practice. I did provide the molar masses of all of these compounds just to speed up it. But you can also practice molar masses to make sure we're pretty close to each other. All right, and that is percent composition or mass percent.